Back in lecture 39, we learned about how to use an SD card for logging sensor readings. Let's go ahead and improve the design from Demo 2 so that the time of data capture is also stored in your SD card. So in the first demo, I only showed you how to wire the real-time clock to the Arduino and initialize the time on it, then periodically read it. In this demo, I'm going to show you how to take measurements from a couple of sensors. I've got a photoresistor and a thermistor here. Take measurements out of these sensors, store the data onto a text file on this SD card, and then stamp each record in that file with the actual date and time when the sample was taken. In terms of the wiring that I've got here, the SD card is connected to the Arduino through pins, digital pins 13 to 10, just like I showed you in the previous lecture on the SD card. And again, the two sensors, the thermistor and the photoresistor, wired with as voltage dividers with a 1 kilo ohm resistor each. And the readings go to the analog pins 0 and 1 on the Arduino. So I'll upload the sketch and see what it does. And we'll go through the sketch and see how it does it. Done uploading, and let's have a look at the output. So initialize the SD card, then start taking measurements, and see if I can make changes to those measurements. Right, so less light going in. Let's increase the temperature a little bit. Alright, so I've already got a few readings, and those are recorded on the SD card. I remove the SD card from the SD card module and plug it into my computer and see what's in the file. Okay, so here's a .log file. Check inside. Right, so we've got all these measurements, and here's a timestamp that was produced with information coming from the real-time clock. The measurements from the sensors. Okay, let's see how this happens. So the first part of this, essentially I've got a combination of the sketches from the SD card module lecture and this lecture. So I need to include the SD card library and then the wire and RTC lib libraries, so that I can use the real-time clock. Initialize the real-time clock object, chip select digital pin 10 for the SD card, start the wire interface and the real-time clock. In this example, I initialize the real-time clock with the date and time on my computer at compilation time of this sketch. Just remember that if you use this method, then every time that you reset the Arduino using the reset button, like this, then the clock will be reinitialized with the time that was with the time at the time of compilation. So essentially, we go back in time. Something to remember. Right. Okay. So the rest is familiar here. I've gone through it, and okay, this is where we take measurements from the two sensors, so analog pin 0 and analog pin 1. We go through them one at a time, grab the readings, and then store them in a data string. So just append each reading after the other. Actually, that happens right here. And here we just have a comma after the first reading only, because we want each record to be comma delimited. Open up the datalog file with write permissions, and then if we have acquired a data file, then start printing in it. And the first thing that we do is to call the print time function and pass the time object and the data file object to it. The print time function is implemented down here. Very simple. Once we have the two references for the date time object and the file object, we just use a file object to print in it the time. So capture time dot year dot month dot day, hour, minute, and second. And all of those are decimals. Print them out as decimals for the human readable. At the end, put a comma, because after the timestamp, we want to print out the data string. So there's going to be the first value from the data string, comma, the second one, and then we're going to close the data file. That's it. We repeat the same process every 3 seconds. So you could make that every 10 seconds or 1 minute, depending on how quickly you expect data to change and what kind of resolution you'd like to have. So that's about it. That's how easy it is to create timestamps in your data logger using the real-time clock module. With the right hardware, keeping time is easy. Try out this exercise. Create an LCD clock. Use a real-time clock like the one in this lecture, combine it with an LCD screen and display the date and time on it. For the adventurers, here's another exercise. Extend the LCD clock so that it has these features: a toggle switch, one rotary potentiometer, a buzzer, and only keeps track of time. Don't worry about the date for now. The toggle switch will set the mode of the clock to time set or alarm set. When the toggle switch is on, then turning the potentiometer will change the time. When the switch is off, then turning the potentiometer will change the alarm time. Assuming the clock keeps time in 24-hour format, make your gadget so that when the alarm is reached, a sound will be generated by the buzzer for 10 seconds.